Hi, my name is Granville Baxa. I'm a junior honors bioengineering student at Clemson University. And today I'll be explaining the concepts of fatigue and stress shielding. So here we were given an example question which asks which of the following describes the phenomenon that occurs when a material is subjected to numerous loading cycles and then fails at a stress level lower than the ultimate stress for that material. Here the answer is fatigue, number 2. So why is that? Well, the definition of fatigue is the tendency of material to fracture by means of progressive microcracking under repeated alternating or cyclic stresses of an intensity considerably below the yield strength. But what does that mean? When a material is subjected to cyclic loads or forces, it can form microscopic initiations. Over many cycles, these can proliferate into macroscopic cracks. Because of the formation of these cracks in the microstructure, the material can fracture at a stress lower than accepted. The formation of these cracks over cyclic loading is called fatigue. So why are the other answers wrong? Well, creep is the quality of some materials to deform when subjected to the same stress or force over area over time. So basically, when subjected to the same stress, it continues to deform as time increases. Toughness is the ability of a material to absorb energy without fracturing. On a stress strain graph, the toughness of material is the area under the curve. Viscoelasticity is the property of some materials to behave differently when subjected to different loads and strain rates. On the graph here, this example of a viscoelastic material absorbs energy as it is loaded, but only partially releases this energy after the loading is complete. Plastic deformation is when a force over a certain threshold causes the atomic structure of material to stretch and shear, permanently deforming a material. Under this threshold, the bonds just stretch, allowing the material to return to its original shape. Our next question asks which of the following is the most accurate definition of stress shielding. The answer is number 1, the decrease in physiologic stress in bone due to a stiffer structure sharing the load. Another way to describe stress shielding is the reduction in bone density resulting from the removal of typical stress from the bone due to the presence of an implant. When compared with bone, metal implants have a higher ratio of stress needed to deform. This ratio is called Young's modulus, symbolized by the letter E. The picture on the left shows the ratios of several materials. As you can see, steel takes more stress to deform when compared to tissue. Due to force properties, the material with a higher value of this ratio carries more load. In a process described by Wolff's law, bone reabsorbs because it is subjected to less stress. The X-ray on the right shows implant loosening due to bone reabsorption. This picture on the left is the result of the force analysis between a metal prosthesis and bone. As you can see, the only difference between the stresses carried in each is the Young's modulus signified by the letter E. Because the Young's modulus of the prosthesis is much greater than the bone, the stress carried in the prosthesis is greater than bone. Well, why are the other answers wrong? The second option is a definition for stored energy in some sort of electrochemical capacitor. This can be seen on the right. Degradation from exposure to a harsh environment is another way to describe corrosion. And the fourth optional definition describes abrasion. This can be seen on the right. The last definition describes a vascular necrosis. In this example in the picture on the right, when the blood supply to a certain part of the humeral head is compromised, the bone dies. I hope this video was informative, and thanks for watching.